We're going to go way back to like 1979, I think. It was the second digital clock I ever built. And this one here, I actually designed this one myself. Well, based on a chip. I had the pin out from the chip. I just had to design the drive circuitry to work with it and come up with a circuit board. And with my high school teacher, we actually made a kit that was commercially sold. Many years ago, when I was in high school, this is 1978 or 79, I forget. But I had a fascination with digital clocks. The first one I built was the Heath kit that used the Mostech chip. The one that my high school, or I guess it was middle school, because back in the day we had our high school at the day, we had two separate high schools. We had a grade 8, grade 9 high school, and then our middle school, and then 10, 11, and 12 was the next high school. And when I was in grade 9, I think it was grade 9, I got for my birthday the Mostech clock chip Heath kit with the Panoplex displays. You guys have seen the second one that I got, because the first one I got destroyed due to the incorrect use of incorrect solder flux at insistence of my teacher of the day that we called Mr. Bonehead, because he insisted that we put solder paste on everything because, you know, he was old school. Anyway, this was my second attempt. This is a clock. It's based on the National Semiconductor MM5314N. This is the chip that essentially replaced the Mostech chip that was used on the Heath kit clocks. It's a 7-segment, 6-digit multiplex display. And working off of just the output, the pinout on this, I designed a circuit to go along with it and did a circuit board layout. Now, back then, when I was in high school, we would do our circuit boards with just draw them with a pen. And my teacher of the day wanted to be able to make this one available to future classes. So we actually had the board done, and he helped me in this respect. This is one of the boards. This was basically a prototype board that we had made. And as you can see, there's nothing labeled. I've written some stuff on there for like which one. This is digit 4, digit 3, digit 2, digit 1, digit 5, or 6, and digit 5. And I wrote the segments over here on here. Now these wires are something completely different. That's just some add-ons that we're going to take a look at in a bit here. But anyway, I basically took the pin out from the chip and, you know, basic common knowledge, you use transistors. It's got 7 NPN transistors over here to drive the segments. I think it's common anode on this, or 6 PNPs and 7 NPNs, I think is what it was. Jeez, it's been so long. I've got the schematic for it. I should go dig it up. But anyway, my high school teacher, being brilliant that he was, this guy, I'm sure he's long dead now because this was 40 plus years ago. I think this was a project for grade 10. Pretty sure this was grade 10. It might have been grade 11. I think this was grade 10. Anyway, so that would make it like 1979 or 1980. Anyway, we took the schematic that I had drawn up and my layout, and basically we masked it out and made a board. And, well, this was one of the first runs of the board. And what he did was he started his own little company. I'm sure that that's the name of another company now, but he called it PPG Electronics because that was his initials. Had some boards made, and we were using them. He was using them for future classes. And in the manual, which I believe this kit, he actually ended up selling this kit to another company that was marketing it. But all I know is that in the manual itself that came with this, the kit version that was sold, my name is in there as an engineer. If you got the manual, it has his name and it has my name in there as engineered by. So and I've got it because I got a copy of the manual. I forget which company he was marketing it through under. It was one of the kit companies back in the day. Anyway, this is a clock. and I haven't used it in many years. I had done many things with this clock. I'm going to show you some of the things, and that's kind of what these wires are for. I'll show you some of the things that I did with this clock over the years, and we'll see if it even still works, because it did work, but it hasn't been used in a while. But check out what I made for it. So this is display number 1. It is wired as common anode. This is display number 1. Hour, hour, minute, minute, second, second. These are blue. These LEDs, which I could reconnect them. This was the first large display I made. And then the second large display I made was this one. This was made out of warm white LEDs. And that's what these wires are for, is how they were interconnected. This was obviously mounted in a box with a big display. I've just taken it apart because I've reused it for other things. And I put this one on a piece of Lexan as I was tinkering around with this one just to see how it would look. And that's what these are, all the jumper wires that connect the different segments together. I had it sitting on top of my refrigerator for years in the kitchen, and you couldn't see any of this stuff. I mean, originally it was just a desk clock, and I had it mounted in a box, which got reused for, I think my Nixie tube clock is in it now. But I took it out and just used it as the driver board to drive a large display. And anyway, I had it sitting on top of my refrigerator for years. Some of these LED segments have burned out. It was kind of an acid test to see how they would perform. We're going to get it hooked up again here and see whether it will work. Some of the wires have been broken because, well, I get cats that like to jump up and go up on top of the refrigerator, and they've been chewing wires. So some of the wires here have been chewed. We're going to put them back together and see whether it works. I know if I plug this in, it should power up. So this clock is powered with 9 volts AC, full wave bridge rectifier, single cap, and then you'll see a half wave rectifier over here with a couple of a resistor and a couple caps. And what this does is this chops the AC signal into a pulsating DC. It's not pulsating DC, it's not filtered, other than these ceramic caps which just take the edge off it. It's a more of a square wave. This is used by the counter because this is AC synchronized. So the incoming AC, and there'll be a jumper down here. I think, that's for 12 or 24 hours. I put a switch over here so I could have it display 12 or 24 hour time. And I put the set buttons fast and slow. I didn't even put the nuts on there. I guess I couldn't find them, and when I put the switches on, I just kind of pushed them through. These used to be mounted on the back. When this was mounted in a box, these used to be mounted on the back so I could set it. And when I took it out of the box, because I needed the box for something else, namely my Nixie tube clock, these then I just stuck them. I just drilled the holes out for the mounting. This was mounted, and with mounting screws, I just drilled these out a bit and just stuck that there because I was just basically going to put it onto a large display and put it in another box. Anyway, let's plug this thing in and see if it turns on. It will, for sure. Oh, it might help if my power doesn't get turned off. There's the time. Got a nice orange display. It actually looks nice just with the LED display. Can switch it to 12 hour. By just doing that, it'll blank the 0. We can set the time. What's it now? It's 2:12. And then the slow button. There's actually a hold button too that you can set to stop it completely for synchronizing it. I didn't hook that switch up, but you can get pretty close to setting to the exact time. It'll keep obviously perfect time because it is AC synchronized, and even in this form it looks great. The orange LEDs look almost like neon, and when you put them behind a glass, a smoked glass, not a red glass but a smoked glass, they look nice and orange. But it's a great little display. And for years I used it like this, just in a box. Then I got the idea of making a big display so that it could be seen from across the room. And this is the display that is not working right now because, well, my cat had a little fetish with the wires. So we're going to put the wires back together. I see one's broken off here. We're going to solder that one back down. That'll put one of the other segments back on. That'll put the E segment back on because it's broken off. So we're going to solder that back down and fix these wires and take a look at this display, and then maybe I'll hook up the other one. I like the white display just because, and I never even finished this, right? I was going to, if you see this trace around here, I have a neon tube. I was going to cut this out and put a red neon tube around here and put it in a box, and I never finished it. I started the project and then I shelved it. Literally, I put it on a shelf, and I put it where I figured it would be for safekeeping so that nothing would get damaged, and put it up on the shelf above the refrigerator. But well, I got a couple cats that decide that they like to go and just chill out and sit up on top of this shelf, and well, as you can see, they've been chewing at things a bit. So let's put the wires back together, and we'll see if it works better. One thing I will say is today we're expecting a big storm tonight. They're calling it up. It's supposed to be starting this afternoon, actually. Any time now. We should hear the wind picking up. They're calling for a bomb cyclone with high winds from southeast. The warning signs have been put up in the neighborhood, warning people that live on the beach that they could get some water coming over the seawall. It'll be interesting. It's going to be an interesting night. We might lose power. They're calling for Category 1 hurricane winds. Okay, this one here, this is one of the segment drivers for the B segment, and it's broken off here, so we're just going to resolder this one back down. So say this was always a work in progress. This, rather than solder them on from the back side, I took them off from the front side here. Just mainly because I didn't want to be soldering on the back side of that board. I don't know how good the board is, so I just tacked these ones on right here onto the where the wires went through, the jumper to the different segments on the back here. So I just took these ones right off these holes that were already in the board, and these ones I just took them off the resistors to drive the segments. So that will get the B segment working, and I'm just going to have to put these other wires back. I can see some more chewed off over here, so we're going to have to put those back together. Just see if I can find some, I don't know if I've got any jelly beans. I might have some Scotch-Lock jelly beans that I can just stick on here. But yeah, damn cats chewing wires. I don't like that because the cat chews a wire, the cat could swallow a piece of wire, and that could make the cat very sick. It could kill the cat for that matter, because a piece of wire poking something in their gut could spill the end of the cat. So good thing I just happened to check this and see that you know, the stupid cat been chewing the wires. So I got some Scotch locks. We'll just put the ones that we know go together here. I color coded everything. I used some of the tips and some of the ring color so that I would have each wire will be a different color. Some will be like a brown or a brown with a white, or vice versa. So I'm just going to put these on. These are what's called an insulation displacement connector, IDC. I'll just put those on there. And I got my 3M pliers. We use these connectors at work, although I have a different set of pliers which I like much better than these ones. I forget where I got these. Picked them up at a swap meet or something, and they're 3M ones, and they're kind of awkward. The ones I've got at work are much easier to use and thinner, and you can get them into tight places, whereas these ones here are kind of bulky, but they do get the job done. You put these connectors on, no problem. And these are great for you know, just quickly connecting, because you don't have to splice in it. You don't have to strip the wire like I did on this end, because I went to stranded. right? These ones are like silicon wires. So I just spliced them on, and I think I soldered them on the other end. Which one of them is broken now? Or one or more is broken, I should say. So maybe know what these pliers being kind of awkward, just to get them into the right place. You've got to get the connector on, get the wire pushed all the way through, and kind of hold the wire in place while you're getting the connector in place. And if the wires are short, they tend to pop back. Imagine doing this when you're standing up a ladder 30 feet in the air on a telephone pole. Okay, that's got those ones fixed. Now, at the other end of this, I see that there's a few more that are broken off here. Which ones went where? Well, I can see the green one went to here for sure. And I've got these labeled, right? I think I've got them all labeled, yeah. That's F. That's the F one. And that one was green. I can see that, where it's been chewed. Bloody cats. Okay, that one is that. And this other one here, this blue white wire, it is it's the is it E? B. B. That's B, which is the one that got ripped off of this one here, the blue wire. I think that's just it. It's just those last two. This one will maybe have to solder this one on because the wire is missing off the end here. I think that's the last one that's damaged. So we'll just tack this one on. I did it like this so that I could easily switch them back and forth. Like I labeled them all, and then I put a bit of the heat shrink tubing on here. That's what that is. And I just did that so that if I wanted to switch back to the other display, I could just either slide the heat shrink out or cut it off and then take the wires off. I wouldn't have to just start rewiring everything again. Okay, the wires are now kind of fixed. Let's see if the display lights up like it should. What's missing? That segment's missing. I think the LEDs are burned out is what it is. Yeah, they're there. They're burned out. These LEDs did not last like I expected that they would. It's got a dead LED on here. It should say 1101, but that part of the segment is burned out. And that's actually the same segment. That's this entire strip here. 3 of the LEDs went out. And that's the problem with a lot of these strip lights, is that sometimes they go bad. Let's just switch this to 24 hour. And where is it here? 24 hour is that mode. I'm going to get it to like 0000. We can see which segments are working and which ones aren't. It looks like this section here has got a dead LED, and this section's got a dead, because 3 of them are working. There's 6 of them in each segment. The way I cut it, because each one is 3, so you got 3. You can cut them every 3. So I got a dead section there, and I got a dead section there. But I thought it looked pretty cool with the display that big. You could read that thing from, you know, across the room, across the street. There's zeros. This one's got a dead segment too. And that's a dead segment. See how dim it is? These LEDs are going bad. I don't know whether it's the resistor on them or it's one of the LEDs themselves. But these segments are just, they're failing. Let's just try putting the heat on this resistor and see if it'll light up. I think it's probably a dead diode. Oh, now it's gone out completely. Oh, that came on there for a sec. It's got to be right here. It's got to be on these stupid resistors that are on here. Let's just try getting it to work. It's definitely right in here, because when I heat it, when I get the heat on there, it comes on momentarily. So it's got to be a bad connection on the on this resistor, on the LED segment, on these three. You see, when I get the heat on there, this thing, it lights up momentarily. Either that or it's the resistor is bad. If you look at how I wired these, I had to create my own wires. That's what all these jumper wires are for. So how these are wired together, if I turn them off so that you can see them, it makes it a little easier. So what I had to do to make these work is each one of these wires, the red wires, is connecting the anodes, or the positive side of these together. All these segments that have positive connections are all connected together. Some of them are bridged over here. You'll see here, if I look over here, some of them are bridged like that to connect the positive together, because all the positive leads for all of these are connected to this one red wire. The red wire down here is positive, that's the anode, because all the anodes are common. So all the positive leads are connected together. So you got a positive lead here, something to point with. Positive for that one, positive for that one. And then the positive goes through, all the way through over to here. That positive is connected to this positive. When we get over to here, the positive leads are connected across here. And the same as the other one here, that one jumps over to there because that's the negative one. You guys can't see what I'm looking at, but see the positive lead here jumps from there to there. These ones over here, positive to positive, etc. Right? All the positive leads are all connected together. They're all wired exactly the same. So all the positive leads for each one of these strips is all physically connected together, and they all arrive here in this next digit. The next digit the same. They're all wired the same. Positives are all connected together. And then the negatives, well, each segment has to have a negative connected. So, for example, this wire here, that's the negative. That's the cathode. And of course it'll show up over here. So this one jumps over to this segment. And this one jumps over from here to this segment. And this one jumps over from this segment to this one. And so on and so on. So all these jumper wires you see going across this display, it might look like a mess, but it's done for a reason. Every single negative on this segment is connected to the negative of that segment, and to that one, and to that one, and to that one, and to that one. The same with all these ones. All the negatives on the top, negative, 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 negative. These all go over to the clock on the corresponding 7-segment transistors that drive the cathodes, and then these 6 drive the anodes. So these transistors are all driving the red wires, which connect all these digits together, and the other ones are on the black wires, which connect all the segments together. It's more complicated than it looks, but it's the same thing that's done on the back here. They're all wired exactly the same. Each digit, the common anode, goes to the positive supply, which is the PNP transistor, and all the cathodes are all connected together. So on the circuitry on the board, all the segments here, that one and that one and that one and that one, all these are all connected together in parallel, and they end up, for example, the A, which is the top piece here, that one, that's A, they all end up on this transistor. B is the next segment down, they all end up on that one. B, C, D, E, F, and G. And then these are the actual digits. That's number 4, that goes to there. That's number 3, that goes to there. That's number 1, that goes to there. That's number 6, that goes to there. And that's number 5, that goes there. I think that's the way it was. Anyway, that's why they're numbered, is to do that. But of course, as you can see with the segments that aren't working here, it makes it kind of hard to read the time. And that's just failure of these strips. I bought a whole bunch of these. I used some for lights. I remember making a cabinet light out of a strip of these LEDs. I had them over my, over the range hood. Make nice bright LEDs over the range hood, over the stove. And they started failing. Just like this. You'd have 3 that would fail, and then you would have another 3 that would fail. And pretty soon the whole strip, you'd have segments that were missing. So it wasn't just in this application that these all started to go tits up, as they say. That's just the way they were. So I think what I'm going to do now that I know that everything's working here is we're going to remove this display and go back to the all blue one. And that should be relatively easy because the wires, I just have to put them together. I haven't run this one in a while. I don't remember there was any segments that were burned out on this. I think they were all good. This one is wired the same way, right? They're all wired on the back here, right? They're all wired on the back. But let's hook up the blue display with the discrete LEDs and see how these ones look. It's bigger. The display is a lot bigger than this one. I was thinking I was going to cut the wires off, but you know what I'm going to do is I'm just going to solve. The color codes are all, I coded these all wires the same. So this one's got 2 strands of Cat5. One that I'm using 7 of the wires, and the other one I'm using 6. And I've got them all so I can just solder them in. That's how I took them off before when I switched over. And I used the same color. I used the same color code when I switched over to this other display and wired it the same. So what I'm going to do is I'm just going to actually undo each of these wires from here and put on the appropriate wire from this display. So blue, there's one. And then my A segment is the blue wire here. Gotta make sure I've got the white ones here. Yeah, this is the cathode. I'm going to continue transferring these wires over off camera, and I'll show you guys the results when I'm done. Alright, that was a fail. Now I remember why I switched out these blue ones in the first place, is because some of them are burned out. I mean, they're different brightnesses. These segments are all wired correctly. Some of my digits are off. My color coding was a little off between the two of them, so a few of the digits are in the wrong position. But doesn't matter because, well, as you can see, some of the LEDs are bad. That's why I changed them out, because the LEDs failed. Because LEDs don't last forever. They do burn out. And that was why I went over to the white ones. So I'll go back to the white one again and try to get those segments that aren't working. Here's this display hooked up again, complete with, I mean, the LEDs, some of these are bad. You can see them flickering. It's going to be the LED that's bad itself, not so much the resistor. It's the LED itself. I think it's gone bad. You can see them flickering away. You see right here, that one's kind of flickering a bit. I think it's the diodes themselves. How these are set up is they have 3 LEDs in series and then a resistor, right? Each segment runs off 12 volts. And so each diode draws about 3 volts. So you get 9 volt drop, and then the resistor takes care of the extra power. And what's happened is the individual strips, what I'm going to need to do to fix this is I'm going to need to get another strip of warm white LEDs and just go and pull these ones out that are bad and stick another segment in. I'll have to get some more. I think that'll be the solution here, is just to go and get another strip. I don't have any more of these warm white LEDs. Hopefully they'll be the same color, because I'd hate to change them and only to have them be a different color. But I think that's probably the only solution to make this actually work properly, is to go and get some more strips. And then I can have my big display clock set up again, because it is kind of cool. Anyway, I tried putting the blue one back on, and as we saw, some of the individual LEDs themselves are gone. Like this one here looks like it's about shot too. There's one that's dimmer. Maybe it's just covered up. Yeah, it's just covered up a bit from the wire. But the other one, some that are all discrete LEDs, and some of them are also bad. Or maybe just disconnect it completely and just use it like it was intended, like I originally built it. It is kind of a neat little project. Anyway, I'm going to leave it at that. At least I repaired the damage on it and got it back working as well as it was before. And at some point I'll get some new LED strips, and we'll change out the ones that are bad. Thanks for watching. We'll catch you in the next one. Bye.